Okay, cool. Thank you very much, everyone, for joining us. My name is Camilla, and I'm one of the conveners of the Cambridge Disaster Research Network series. And we're very excited today to have a seminar on the economics of disasters. And we're hoping to approach this from quite a lot of different perspectives. So hopefully we'll have plenty of time for discussion, and I'd encourage you all to think of questions and pose them. And yeah, let's hope that we can get an interesting conversation going. I'm hesitant to take up too much time because I want to make sure that we have plenty for our panelists and for discussion. But I'll just briefly introduce each of the speakers as we go through the talks. And then after they've each given a brief introduction, we'll have lots of time for discussion. Okay, so our first speaker today is Dr. Emily Wilkinson, who is a senior research fellow at the Overseas Development Institute, where she works in the Global Risks and Resilience Programme on incentivizing investment in disaster and climate risk management. And she's also the Chief Scientific Advisor to the Climate Resilience Execution Agency for Dominica. But today she's going to talk to us about the triple dividend of resilience. Take it away, Emily.
Thank you very much. And I will just share my screen and hopefully that will work. Okay, so today I'm going to tell you a little bit about this triple dividend of resilience framework and how it's been applied. But let me start by outlining why we need to talk about resilience dividends and why it's kind of come onto the agenda. So I'm going to oversimplify, but what we have is a situation where when we think about disaster risk management and investing in actions to manage and reduce risk, disaster risk, there is an incomplete analysis of the benefits of those investments. So we don't really see the benefits until there's a disaster and the losses have been avoided. And so that for policymakers is not enough of an incentive for them to prioritize investments in managing risk as much as would be optimal. So we need to change the way in which investments are appraised and evaluated. That's clear. There needs to be a much clearer understanding of how to conduct those kind of appraisals, and to see disaster risk management, adaptation and resilience as a way of securing growth and development, so not just to avoid kind of humanitarian impacts, economic losses further down the line. And I've just included a couple of pictures there of some publications which are relevant to this topic and have really been highlighting that kind of approach and that rationale. So the political economy of resilience, and just to kind of go into a tiny bit more detail on that, and why this kind of support for resilience is not as high as we would, it's suboptimal, it's not as high as we would like it to be. This is despite the fact that there's been strong support from the international level in international agreements, policy frameworks that are all about resilience, it's across all of them. But even benevolent governments and certainly businesses continue to suffer from myopia. And the reason for that is, well, they're complex, and it depends obviously on the country and on the business, but lack of resources, particularly in developing countries, a limited understanding of risk and impacts, and particularly important is the lack of salience with citizens. There is certainly greater buy-in for more visible post-disaster support and the availability of humanitarian assistance. So that can also act as a disincentive to investing upfront. And the certain immediate costs of those investments have to be weighed against the future less certain benefits. So that's the kind of understanding the current political economy of why we see an underinvestment in disaster risk management. So that led us to work with World Bank and LSE on a framework for thinking about the dividends of investing in disaster risk management. It's called the Triple Dividend of Resilience Framework. And it has three parts to it. There are three dividends. The first one is what you would expect, the benefits associated with avoiding losses when there is a disaster. I won't go into that. I think that's the one that we're most familiar with. The second dividend of resilience is a slightly trickier one to think about. We call it unlocking economic potential. It's basically the idea that if you create a lower risk environment, so this can be through a series of interventions and investments. It's not associated with one project in particular, but if you can reduce the level of risk in the environment, then individuals, households, businesses will take other kinds of positive risks. So they'll do things that will increase productivity. They'll make investments in capital, make capital investments that to improve their businesses. So there'll be actions taken as a result of that perception of the environment being safer, which will produce economic dividends. And we also hypothesize that there'll be changes in land value. That's not been well studied yet, but that the land values will go up as a result of having a lower risk environment. The third dividend of resilience is about co-benefits, and they are associated with particular projects or investments. And you'll see, for example, that quite a common example would be sort of investment in mangrove reforestation to protect coastline, to protect infrastructure, which also has benefits for the local ecosystem and health and other co-benefits. So those are the three resilience dividends. And this is really just a framework for sort of separating those out and making sure that we consider them in appraisal and in deciding what kind of investment is needed and how much. This framework was applied to analysis of adaptation options in a paper by the Global Commission on Adaptation, and they conducted a kind of modelling exercise based on existing cost-benefit analysis from different sectors of what the benefits would be of an investment of $1.8 trillion in across five areas or five sectors. This is really just illustrative. I think, you know, these are not real numbers, but it does indicate that if you use this kind of framework and you look at the three resilience dividends, that you can produce some quite significant net benefits. So, you know, really the idea of the paper and of using the resilience dividend framework in it was to demonstrate that there really are important benefits associated with investments in adaptation and resilience that go beyond just the kind of the losses that might occur when there's a crisis. And finally, I think I have time. I wanted to just go into a little bit more detail on one case study, because it's great having the framework. I think it helps to kind of focus the attention on some areas that you might be missed off in project planning if you're not thinking about them. But, you know, can we actually observe this in a particular case or place where there has been investment in disaster risk management? So we took the example of a very large early warning systems project in Tanzania that was kind of rolled out nationally, but particularly focused on coastal areas, supported by the UK Met Office. And there they wanted to improve the capacity of the Tanzanian Meteorological Association agency to deliver impact-based 5-day weather forecasts to coastal areas. And the results were really interesting. So we didn't get to the point of kind of quantifying this, but did a lot of kind of focus group discussions and interviews to kind of drill down into these resilience dividends. So what we found was that, yes, people were taking more precautions based on the weather information that they received. So the early warning systems were actually reaching people, and they were responding to them, taking decisions based on that information. And there was a perception, certainly, of reduced mortality and property damage as a result. So when people had better information about the weather, would be able to act on it. So when there was a forecast of an extreme weather event, they could take their boats out of the water, not go out fishing that day, take action to protect themselves, go to shelters, and so on. The second dividend of resilience was interesting. There were certainly some examples of fishermen being able to, wanting to make some capital investment based on this, the fact that they trusted the information, they had good information, and they could use that in their kind of business decisions. So they were, some fishermen reported being able to buy new fishing gear, motorboats, switching to better vessels, some of them engaging in new activities like water sports, all of this on the assumption that they're not going to be damaged, they're not going to lose these investments as a result of extreme weather. But overall, these were not widespread. It was really only, there were sort of a few cases of fishermen being able to do this. And then the third dividend of resilience is about better planning. And this was kind of reported across a large group of stakeholders that we spoke to, that the training activities and the community meetings and so on had helped people to plan better their activities, so they could, for example, take decisions when the weather was good to go out for longer, catch larger quantities of fish, and when they expected the weather to be bad, they would switch to other income generating activities, so that they were able to make better decisions sort of on a day-to-day basis, not just in terms of very extreme weather events. Overall, and to conclude, we saw it was interesting to dig down into this case study, because what we see is that the risk from extreme weather, or the disaster risk, is only one of the obstacles preventing individuals from investing in more risky and profitable activities. So yes, lowering the risk environment is important, but it's not enough in and of itself to prompt the kind of changes in the second dividend of resilience that you might expect to see, because actually not everyone can use the information and respond to that lower risk environment and increase investment in the same way. Certainly this would need exploring in more detail. We need to collect more data and look at complementary activities. So having a good early warning system is a great start, but would probably need to be accompanied by, for example, microfinance to help people to buy the new equipment, to make the sort of investments that they want to make based on this improved information. So I will leave it at that. I'm very happy to take questions and a discussion later on. Thank you.
Thank you very much, Emily. That was great. I'm going to move on now to Dr. Farnaz Mahdavian, who is a researcher at the Karlsruhe Institute of Technology. Farnaz works on societal preparation and response to disasters, and also the factors controlling post-disaster recovery. She's going to talk to us today about the role of insurance in disasters. So Farnaz, go ahead.
Hi. I suppose Marcus start first, if that's okay with.
Sorry, yeah, I should have asked with you. So Farnaz and Marcus are both at the Karlsruhe Institute of Technology, and they are kind of sharing this slot. So we'll start with Marcus then. So Marcus Wiens is the head of the risk management research group at the Institute, and he's going to talk to us today about some aspects of behavioural economics. And then Farnaz will do the second half of that section.
Can you see the slides? Yeah.
Now we can see them. I can hear you.
Okay, second. Can you see them now?
Yeah, perfect.
Okay, great. Yeah, thank you, Camilla, for the introduction. Farnaz and we make this this presentation together, and I start with the part of evacuation compliance, which is a model decision theoretic and a game theoretic model. So it's a little bit more from a theory perspective, and after that, Farnaz shows you results of an empirical study. So she has the empirical perspective on that topic. Yeah, what is the evacuation compliance model about? So this is the decision theoretic model. The motivation is that many policies, in particular disaster management, cannot be forced. So you cannot force people to do things, to prepare themselves, but you depend on their compliance. And to take these compliance effects into consideration, we set up this model. We wanted to understand how can you model decisions like evacuation decisions or government or authority decisions which trigger an evacuation and which are of course analyzed on an empirical basis already. How does compliance change this? So what matters, what aspects of this decision have to be taken into consideration? And one aspect which has to be taken into consideration is the communicative interaction between the authority and the public. So here you need a kind of communication game, which is important that it's important what you say, and it's important that what you say has credibility from the perspective of the addressees. And the second is the public beliefs about the authority's intention, competence, or reliability. And these three elements are elements of trust, and therefore you need trust. In our model, we focused on competence-based trust because we assumed that the government has a better expertise on the impact of a flood, because a flood is now the context, the disaster context for this model. To give you a brief impression of a brief snapshot of the idea here, just assume that you have a region, or two regions in fact, which are close to a coast, and region A here, this red one, is flood prone, and region B is more in the remote area. So here there's less risk, but this depends of course on the event itself. So if you have a very extreme flood, it can also affect region B as well. And therefore you have to deal with these two regions. This was one objective of this model, because we wanted to analyze differential communication, not just to one group, but to communicate to two groups, which makes it a little bit more complicated because each group can observe the communication and makes, of course, some interpretations of that. And and then in the model, the structure, here we have a so-called hidden Markov chain. It looks complicated, but it's quite easy. We have just three states of nature, which we assume just a simplified setting because we were just interested in how these basic elements interact. And the three states are S0, which means there's no flood. S1 means there's a serious flood for region A, and S2 is a state where region B is affected. So the S2 is an extreme flood. And we looked at all transitions, and we underlined the whole sequence of events by an early warning system. So this is a Bayesian approach where you have conditional probabilities, and where you can apply also empirical values for these matrices, or for these conditional probabilities. In our model, we assume that the early warning system of course also has some mistakes, if you want. There's no perfect forecast, but that the level of forecast is the quality of the forecast is the same for the government and the people, but just in terms of impact, the government has an informational advantage. Just assume, like the COVID-19 event, for the probabilistic part of our COVID-19 pandemic, we have nearly the same information, because we see all the statistics about the infections, but we have probably some doubts, or people have doubts about the impact. So some feel that they are probably not so in danger than others, and this this is of high importance for the compliance issue. This is the general model structure. I just briefly described that. That's more detailed if you want to go for this due to time reasons, just to go quickly over it. What is important here is the first T0 decision, because we do not just assume that government makes a short-run decision in the event of a disaster, but we also assume that government can make a decision before the disaster. And this is here about investment. So we assume scalable investment in congestion, in reducing congestion. So you can, for example, run information campaigns, or you can, for example, make contracts with bus services to prepare faster evacuation, or you can even construct additional routes. So you can see, you can even flood, and we see the signals, and then government decides about whether to evacuate, make an evacuation order or not, and to which group. And then the groups observe that, and depending on their trust level, they decide whether to evacuate or not evacuate. Yeah, what is the results? There are many results because this is a simulation, of course, a theoretical model and a simulation. What you can see in this diagram here is a three-dimensional picture of showing the cost, the damage cost for the whole region from the perspective of the government. So this is the highest damage here on that level. And this highest level is associated with a very low trust level. So if people have a very low trust level, government has no chance, no possibility to reach the people. And as government has the informational advantage, they cannot prevent people from the disaster effects. If this first critical threshold, the low trust level here, the low threshold is reached, then you see a sharp drop in the cost, and the damage cost. This is due to the first group, Group A. So Group A just needs a very low trust level because they are, of course, in a flood-prone region. They are more sensitive to these changes. So even if they doubt government, in most cases, they will evacuate anyway. So they need a very low level. And this is also not dependent on the investment here, because this is a second dimension, because investment matters for congestion. And if the smaller group in the very close, in the region which is very close to the coast, is affected, then you have a smaller number of people. So congestion is not an issue here. But if you have look at the second group, then you see that you see a second drop, and the second drop can just be realized if you have a very high trust level, because the second group is more demanding in terms of the competence and the government messages. And here you need the investment into congestion reduction, because if it is an extreme flood, then also the remote population in region B has to evacuate, and this creates this enormous congestion problem. This is just the illustration of this scenario. And to sum it up, the other results of this part, the compliance problem can be overcome by at least one of the following conditions. You need either high precision of the early warning system. So if we increase the precision, of course, you can prevent the problem. So this is in line with what Emily said before, that you can do something before to also solve compliance problems, by the way, and also high competence trust in the government. And of course, the congruence of preferences must be high. So government also should be believed to act in the interest of the domestic people, and for example, not in the interest of tourists, for example. And what is also interesting is that for very extreme events, investment matter. And if investment matter, it has a higher impact on damage reduction than the pure compliant problem. But nevertheless, investment and trust are more sensitive, so they are more interdependent for very extreme events. So that means if you really want to prepare against the very big event, the extreme flood event, then you should more focus on investment. And here This is also of interest for the insurance. So we see a relevant empirical link here between the evacuation intention and insurance, which is there's lots of research about this interrelation, and insurance can, of course, because we see that people buy insurance if they have a higher risk awareness and if they care more for their belongings. Yeah, and if they, this can lead to this problem that they probably do not evacuate immediately because they want to protect their belongings. And insurance could also set incentives for reducing investment in terms of congestion reduction. These would be the recommendations from this part. And now I hand over to Farnaz.
Thank you, Marcus. So following Marcus' talk about evacuation and trust, here is just one of the results from our survey among the German people who are affected by flood, and also some people in UK who are affected directly by flood. And the result shows that people don't have high trust in government in general. But as you see, still during the emergency, these people followed government order for evacuation. Next slide, please. Thank you. So, but now I want to talk about the disaster recovery framework, which is developed at Cambridge Center for Risk Studies for the project funded by Access Excel Insurance for researching about the role of insurance capital in improving economic resilience. Next, please. So, we see recovery as a process of resilience building, and a resilience as the capacity to spring back after the initial shock of a disaster. So improving resilience requires more time and resources than what it would have needed to be recovered the same level as before. And as you see here, there is a window of opportunity in the early phase of recovery to improve the resilience and try to build back better. Next slide, please. So we actually invested so much time to understand about the factors affecting recovery. So therefore, we studied in detail for 103 cases worldwide. And as you see here is a characteristic of our database. We focused on 50 countries, which are distributed all around the globe, and they have different economic types, they have different income group. We considered 4 types of disaster, mostly from 1950, with and disasters are having different severity. Next one, please. So we developed this framework to understand the recovery, and here what we call disaster recovery framework. So for every disaster, we consider 2 classes of factors to analyze for speed and quality. First one are the given factor, as you see them in the blue, which represent the characteristic that can't be directly managed. These are including pre-existing socio-economic condition and the disaster load, which incorporate all the damages and losses for different sectors. And next one, please. Red boxes here, we consider the manageable factors, including the sources, adequacy of the funding, the speed and the funding, and these are manageable. And having these 2 classes of data, in fact, we can analyze the recovery in more detail. And we break out this framework to different categories, as you see next slide. Yeah, there are 7 main categories in our study, including disaster profile, antecedent condition, disaster load resourcing, organizational factor management, and recovery, which all of these main factors categories have their own different sub-indicators, which some of them even go beyond like 7 or 8. And we analyze them for understanding mainly the role of the insurance company. And next slide, I'll show a couple of results. So each percentage point increase in insurance penetration, we understood that reduced the recovery time by almost a year. And even in countries with high insurance penetration, which we consider like 4%, have an average recovery rate of about like a year, while countries that have very low insurance penetration may never recover or take longer than 4 years in case they still recover. The quality of recovery for high insurance penetration countries is better, and economic recovery is faster than societal recovery in over 50% of the cases. Speed and quality of recovery are not mutually exclusive because we actually found a couple of cases that satisfy these both outcomes. I tried to be very fast.
You did a great job. Thank you very much. And thank you very much, Farnaz and Marcus. That was brilliant. And finally, we have Dr. Jana Vasowicz, who is an assistant professor in sociology at the University of Durham. I was excited to find out today that she has 2 PhDs in both sociology and social anthropology. So she is very qualified to comment on these issues. And her work looks at the politics of knowledge production, which she's going to talk to us about today in the context of disasters. So go ahead, Jana.
Great. Thank you, Camilla, and thank you, everyone. I'll get started. So my remarks are going to be from a slightly different perspective, as Camilla has already hinted at, but I think they will speak directly to some of the things that Emily and Farnaz and Marcus have raised as well. And in particular, I'll be talking a bit about the assumptions concerning knowledge, and in particular, the relationship between knowledge and action. And what matters from my perspective as a sociologist in particular is whose knowledge are we actually talking about. So the relationship between knowledge prediction and intervention is something that's assumed to inform substantially the relationship between, well, disasters and disaster management, as well as disaster prevention. And recently we've seen, and not so recently, we've seen a number of examples where governments have failed to predict some things that, according to some people, should have been knowable. Most recently, obviously, the COVID-19 pandemic, not only the pandemic itself, which had been predicted by a number of risk scenarios in the past, but also things such as, for instance, the fact that the virus would mutate. And I've just included some snippets from different kinds of media coverage in the UK, indicating that basically with anyone with A levels in biology would have known that viruses would mutate, and some of these mutations could in fact become more difficult to manage, including by both, including by pharmaceutical interventions that we have at disposal. Another famous example of non-prediction, a relatively recent one, is the absence of prediction of the 2008 economic crisis. So in that sense, when we talk about the relationship between knowledge and prediction, I have always been interested not so much in how we can predict better, but more in the question of the failure of predictions. Why do governments fail to predict disasters and other kinds of disruptive events? And here are some of the main or most influential answers that have been given to this question in the past. One is obviously that the nature of risks is complex, and thus that different kinds of risks are unpredictable. The other is that there just isn't enough knowledge. Obviously, in the past, this meant that there has been a low level of scientific development. We just didn't have the technology or the knowledge to predict. Or in more recent forms, that there is a miscommunication, and this is obviously framing it somewhat euphemistically, between scientists or experts and policymakers, so that in fact scientists do have enough knowledge to predict disasters and disruptive events, but that policymakers are not listening. So this knowledge is not, as it were, filtering through. Sometimes the explanation is that there isn't, not that there isn't enough knowledge, but rather there is too much of the wrong kind of knowledge. And this is something that we often refer to as epistemic capture. So for instance, that a specific group of scientists or a specific discipline is able to monopolize the attention of policymakers to a degree that makes it impossible for any kind of contending narrative to filter through. And obviously in some cases, contending narratives will be closer to the truth. Then obviously the explanation that, again, what we could perhaps somewhat euphemistically frame non-cognitive interest or non-cognitive reasons, such as, for instance, political interest, from outright censorship to intentional stirring of doubt, such as, for instance, in the case of climate denial or climate skepticism, play the more important role. And then last but not least, we come to something that my colleague and collaborator Lindsay McGooey has explored as the concept of willful or systemic ignorance. And I want to make clear that systemic ignorance is not the same as denialism. So it's not intentionally obscuring information. It is more about creating and reproducing systems that allow certain kinds of, well, absence of knowledge to be perpetuated. Just a brief sort of run through the last 500 years of human history, as we are sometimes wont to do. It's a joke, but briefly, the association between knowledge and prediction in modernity has more or less been linear. So the idea is that more knowledge, by definition, leads to more accurate prediction, and that this makes interventions more efficient. However, in late modernity, and Ulrich Beck is one of the sociologists who've tried framing the changing nature of risk in late modernity, the nature of governance of risks also changes. And Beck, who framed or coined the term the risk society, claimed that more recent risks, so risks that have become prominent in the late 20th and the beginning of the 21st century, are obviously not limited by time or place, and we have seen this reflected in the models in the two preceding presentations, that are not accountable according to the established and he meant modern rules of causality, blame, or liability, and that cannot be compensated for or insured against. In that specific sense, he was obviously wrong, or rather he was writing before the rise of green finance, but he also meant that it's impossible to construct systems of compensation or insurance that would be in that sense foolproof. From a sociological perspective, we see risk as the social framing of uncertainty. And in this sense, what interests me specifically is how different participants in the social sphere see risk and uncertainty, not only for predicting what will happen, but also for understanding or explaining different kinds of social processes. The other thing that I'm particularly interested in is how different actors see others' knowledge. So what do other people know? What do we assume about the knowledge of other people when we talk or think or plan for risk and its management? A very important distinction from my point of view, and this is something that I want to emphasize at this point, is the distinction between knowledge and perception. I think this often gets mixed up. So when we talk about knowledge, we talk about something that is necessarily interpersonal or to a degree public. It is communicated, so through obviously different formats. And its distribution is structured by different kinds of inequalities. One obvious example of a structured distribution of knowledge or ignorance is, for instance, access to education, but also access to internet. Again, not in simple terms, because obviously internet can also be used to spread misinformation or conspiracy theories, etc., something that we've seen plentiful evidence of recently, and other things such as public trust and social integration. As opposed to that, perceptions are usually framed as private or individual. People's perceptions are their own, although obviously they can be similar among a number of different people. Perceptions can usually be assessed through, for instance, opinion polling. Perceptions can also be shaped or influenced. influenced, as opposed to knowledge, which is longer lasting and actually more difficult to shape. Now, the interesting difference between perceptions and knowledge comes in how they shape action. So perception is assumed to lead to more or less direct, or has more or less direct consequences for action. And these kinds of actions are usually either binary or clearly discernible. So for instance, perceptions shape our voting preferences. So we vote for one candidate or another, or we choose between a number of candidates, or for instance, wearing a mask or not. So that kind of choices. But when it comes to knowledge, which is more complex, more difficult to shape, and more difficult to change as well, knowledge does not automatically translate into action, or at least not on its own. And this is what makes it such a complex social object. I've included here two favorite examples. One is obviously doctors who smoke, the other is environmentalists who fly. In essence, knowing about the link between, say, smoking and certain kinds of cancers does not mean that everyone who knows about this link, including who knows very well, so who possesses specialist knowledge about this link, does not smoke, much like awareness of the relationship or the amount of carbon emissions contributed by flying does not mean that all of us who are aware of that stop flying. And this is quite important for understanding how different kind of political actors model public knowledge. Now, what I have argued in the recent, or well, still forthcoming paper with one of my collaborators is that we're seeing a shift, so a very distinct historical shift in terms of how different kinds of governments or different phases of governance think about knowledge and ignorance. And liberal governments, or classical liberalism, traditionally saw the intervention into education or information as a key element of prevention or mitigation of different kinds of risks. Public health campaigns are one obvious example. Universal education is also one obvious example. So the key assumption is that the public can be educated or educated out of ignorance. Later shift to neoliberal modes of governance emphasized market mechanisms and thus the distribution of both risk and the ability of different members of the public to choose. The late liberal phases of governance, which we kind of associate with the end of the 20th century and the beginning of the 21st, suggested that perhaps, given that the public doesn't always choose well, regardless of the amount of knowledge they have, they can be slightly influenced into making the right kind of decisions, obviously meaning decisions that are optimal for everyone from the perspective of the political actors who are able to shape choice architectures. What we are arguing, however, is that the most recent phases of management of some kinds of risks and disasters, and again, we're basing this on our analysis of the COVID-19 pandemic and specifically the strategy of the UK government in managing or not managing the COVID-19 pandemic, is that we're seeing a mix, a new emerging rationality that combines some of the previous modes, but with a distinctly interventionist bent, or with a return of interventionist bent. What does this mean? It means that often this kind of approach uses the assumed absence of public knowledge in order to justify interventions that are deemed to be, or are deemed expected to be, unpopular. So rather than aim to educate the public about risks, so rather than aim to change public knowledge, because changing public knowledge involves a relatively high and consistent, meaning in economic terms, expensive, costly, amount of investment, including in education, including in public health, and so on and so forth. The emphasis is on short-term messaging, and the emphasis is on short-term messaging that amplifies the possibility of the public assenting to measures, even though they might have opposed these measures initially. And this is often done by actually creating otherwise preventable disasters. I know that this is a relatively complex framework to comprehend, and I'm also aware of the fact that I am nearing the end of my my presentation time. So I'm going to leave you with this. Well, I'm going to leave you with these two questions, which is something that I'm very interested in exploring further. One is obviously, how does this relate to different political and economic systems? Because not all governments are equally comfortable with different degrees of intervention or different degrees of non-intervention for that matter. And how does this impact other kinds of risks, including most specifically climate governance in the future? That's it.
Brilliant. Thank you very much. Okay, I'm going to